kiddos, we're getting into lesson 13 here in just a moment. Like I mentioned today in class, in lesson 13, we are going to be using the standard algorithm to multiply mixed numbers. In order to do that, we're going to need to transform the mixed numbers into improper fractions. Our resulting products are going to be improper fractions, so we're going to have to use long division to simplify them. So I really need you guys to think about what we talked about. I just had a serious talk with both classes. I need you to slow down. I need you to do your best work. I need you to understand that, yes, it is the end of the school year, but yes, we still have a ton of work to do, and I want you to finish 5th grade strong. I do not want you to just kind of taper off and not be your best self, because you guys are all capable, you guys are all brilliant and hardworking and wonderful mathematicians, and that's who I need to see every single day. So take a look at what we're about to do, think about it. If it doesn't make sense, pause, rewind. But I need you to have a pretty solid understanding, pretty solid idea of what we're going to be practicing in class tomorrow after you watch this video. So for some of you, you might need to watch it a couple of times. So without further ado, here we go. Okay, kiddos, we are going to start leaning into this traditional algorithm that we are going to use when we're multiplying mixed numbers together. So moving forward, we're going to convert these mixed numbers into improper fractions and then just do multiplication. I want to show you guys, though, why that works. And I'm going to use our area model, the same area model that we've been, I don't know why that's flipping, the same area model that we've been using all week. So I'm going to go ahead and just label this rectangle as 2.5 feet wide by 1 1/4. And then we're going to get into a little bit more precise labeling here. So let's go ahead and decompose 2.5 into 1/2 and 1, which is going to be equal to 2. This modeling is not modeling that we're going to be doing in class necessarily, but I just really want you guys to understand why it works. Well, first of all, why do we need to transform mixed numbers into improper fractions in order to multiply them? And then also, once you're successful in doing that conversion, I want you to understand and be able to see why it actually works. I'm looking for like a thicker, there we go. So we have decomposed 2.5. Hi.
Good afternoon.
2.5 to 1 1/2. So we have 1 whole here, we have 1 whole here, and we have 1/2 here. And then on this side, we're going to decompose 1 1/4 to, there we go. We're going to decompose 1 1/4 to 1/4, and again, this is not proportional. And 1 whole. Okay, so we've decomposed, thank you, Mr. Folkman. We've decomposed 2.5 to 1 2.5, and we've decomposed 1 1/4 to 1 1/4. So now I want you to think about, what are these mixed numbers actually equal to? Well, within 1 whole, how many halves do we have? Well, within 1 whole, we find, oops, I wanted a purple. Within 1 whole, we find 1 2/2. Again, over here, within 1 whole, we find 1 2/2. So let's go ahead and relabel our 1 wholes as 1/2, 1/2. So my 1 whole is equal to 1 2/2, and my other whole here is equal to 1 2/2. Okay, interesting. So here we have 1 1/4. How many fourths do we find inside 1 whole? Well, interestingly enough, within 1 whole, we find 4 fourths. Okay, cool. So let's label that. I keep on grabbing like a bright color, and I'm coming up with kind of drab color here. Okay, that's better. So within 1 whole, we will find 4 fourths. You guys have an excellent grasp on that by this point. So within one whole, we find 1, 2, 3, 4 fourths. Let's go ahead and label that as such. We will label 1/4, 1/4, 1/4, and 1/4. Again, this is not proportional. Okay, so now we've rewritten 2 1/2 and 1 1/4. So 2 1/2 up here, we've rewritten as 1, 2, 3, 4, 5 halves. We've rewritten 2 1/2 as 5 halves. 5 halves is the improper fraction form of 2 1/2 because within 2 1/2 we find 1, 2, 3, 4, 5 halves. Okay, cool. And then let's look at our fourths here. Within 1 1/4, remember we had 1 whole and 1/4. Within 1 1/4 we find 1, 2, 3, 4, 5 fourths. Interesting. So now what we've done, you guys, is we've transformed 2 1/2 into 5 halves. And we've transformed 1 1/4 into 5 fourths. Again, we've just transferred our mixed numbers into improper fractions. And now can you see that we can very simply just multiply straight across? 2 times 4 is 8. Within this dark outline, within this kind of black marker outline, I'm going to go over it in red, is 1 whole. Remember, we initially labeled this as 1 whole and then we broke it down into fourths. Within this 1 whole, we have 1, 2, 3, 4, 5, 6, 7, 8. Excellent. Okay, so we have 2 times 4 is 8. Beautiful. 5 times 5, you guys are so clever. Thank you, Anna. 5 times 5 is 25. Indeed, our rectangle, our full rectangle here, has dimensions of 1, 2, 3, 4, 5 halves by 1, 2, 3, 4, 5 fourths. So 5 halves times 5 fourths is equal to 25 over 8. That is an improper fraction that needs simplification. I can pull 2 wholes out of that. I just pulled 16 eighths out of 25 eighths. Let's figure out how many eighths we have left. I'm just going to use this space as some scratch paper. We're looking at 25 minus 16. 15 minus 6 is 9. So what we're left with is 2 9/8. As it turns out, we can pull another whole number out of 9/8. And what we're going to end up with is 3 1/8 as our final answer. Another way that we could have simplified 25 over 8, friends, is by dividing using long division, 25 divided by 8. So here is why improper fractions work. Here is why we can take this mixed number and turn it into an improper fraction. And once we have it, our mixed numbers in improper fraction form, it's just very straightforward multiplication. Isn't that just mind-blowing? I love that. Math is beautiful. Grab your tissues. We are going to do this problem without modeling. I know that a lot of you were probably feeling very emotional about this because you love modeling. So we are multiplying 5 4/6 by 4 3/5. These are mixed numbers. Before we multiply, we have to transform them into improper fractions, and here's how. No, I'm not going to model like I did in the previous problem every single time because I'm already old and I don't have time for that. I don't think I would survive many more of those models. But the model that I just showed you is really important. I really hope it gives you a great idea as to why what I'm about to do works. And if you don't understand why this works, rewind and watch it again. It's Oscar worthy. It is just such beautiful math in practice. It's awesome. Okay, so 5 4/6 is composed of 5 plus 4/6. I need to translate 5 into sixths language. Well, I know that 1 is equal to 6/6, but I don't want 1. I need to translate this 5 into sixths language. So the way we're going to do that is we're going to multiply 6 times 5. So I'm multiplying my 5 wholes into a really improper fraction. 5 wholes is equal to 30 over 6. Don't believe me? Let's rewrite 30 over 6 as a division expression. What is 30 divided by 6? It is 5. Wow, she was right. Okay, cool. So 5 and 4/6 is equal to 36 plus 4/6, which is equal to 34/6. 5 and 4/6 is equal to 34/6 because there are 36 inside 5, and then we have to bring 4/6 along to the party. The way that we figured this out is all we did was multiply 6 times 5. 6 times 5 is 30. 5 wholes is equal to 30 over 6. Confusing? Let's just rewrite this fraction as a division expression. 30 divided by 6 is 5. Okay, cool. So now we've rewritten 5 and 4/6 as 34/6. Now we need to rewrite 4 and 3/5 as an improper fraction. So let's choose a color. I'm going to choose Cubs colors. So 4 and 3/5, I'm just going to go over here, is equal to 4 plus 3/5. We need to rewrite 4 as fifths. You guys know that 1 whole is equal to 5/5, but I don't want 1 whole. I want 4 wholes. In order to rewrite 4 wholes as fifths, we just need to multiply 5 times 4. Well, 5 times 4, thank you, Arwen, is 20. 4 is equal to 20/5. Don't believe me? Let's just rewrite 20/5. I'm going to do it down here. Let's just rewrite 20/5 as a division expression. You guys know any fraction can be rewritten as a division expression. 20/5 is equal to 20 divided by 5. What is 20 divided by 5? It is 4. Great. So 20/5 is equal to 4. We are trying to change this mixed number. We're not trying. We are actually nailing it. We're doing an amazing job. We're rewriting this mixed number as an improper fraction so that we can multiply these two values together. So 4 is equal to 20/5. Bring 3/5 along, and let's rewrite 4 plus 3/5 as an improper fraction. We just have to add 20 plus 3 together. 20 plus 3 is 23. And there we have it. So 23/5 is equal to 4 and 3/5. This is the improper fraction. This is the mixed number. Let's go ahead and now collect both of our improper fractions, and we just have to multiply, and life is going to be good. So now we have 34/6 times 23/5. So all we have to do now is just very simple multiplication. We have double digits times single digits. I hope everyone has 6 times 5 at this point. Thank you, Miles. It is 30. We need to figure out 34 times 23. I'm just going to use some digital scratch paper over here, and I hope I have enough room. So we have 3 times 4 is 12. Carry the 1. 3 times 3 is 9, plus 1 is 10. I'm going to write teeny tiny. 2 times 4, nope, 20 times 4. That's why I inserted my 0 here. 2 times 4 is 8. And then 2 times 3 is 6. Okay, good. I'm going to find the sum of these two partial products. We will end up with a 2, an 8, and a 7. I know this is not aligned. I just want to make sure you guys could see that addition. So we have 782/30ths. That is one improper fraction. How can we simplify this improper fraction? Well, we did a little bit of this over here. I know that I can rewrite any fraction as a division expression. So let's go ahead and divide 782 by 30 using long division so that we can have a much cleaner, tighter version of this insanely improper fraction. So we're dividing 782 by 30. And we're just going to enjoy some long division. How many 30s go into 78 with some left over, Ollie? Thank you. 2. 2 times 30 is 60. Now we need to, first of all, make sure we're really staying aligned with this long division. If you shift over to the left or the right in the wrong place value, you can end up with an incorrect number, even though you might have the correct digits. Place value is very important, as you guys know. 8 minus 0 is 8. 7 minus 6 is 1. Here's a step that a lot of you guys skip over. Once you find the difference, you need to check yourself. Is 18 smaller than 30? Yep. If the answer was nope, you would know that you could squeeze another 30 into 78. But yes, 18 is smaller than 30, so now we know that we can move forward. Let's bring down our 2. And now we need to think about, how many 30s fit into a 182 with some left over? Well, I know that I'm just going to look at the first digit. I know that 3 and 18 are really friendly. I know that I can fit 6 3s into 18. So we're going to use the same knowledge for 30 into 82. We're going to say that we can go ahead and fit 6 30s into 182 with some left over. 6 times 3 is 18, but that's not a 3, it's a 30. So 6 times 30 is 180. What is the difference here? It is 2. So when we simplify 782 30ths, we are going to come up with 26, and we can rename our remainder as a fraction. That is totally acceptable. What we have here is 26 and 2/30ths, or 26, 2/30ths can be simplified to 1/15. Okay, there was no modeling. I hope you guys can move forward in a really, really successful way. There's a lot of calculations going on here. We are adding. You guys know how to add. We are dividing. Wow, you guys know how to divide. We are multiplying. Handled that in Module 2. We're doing long division. You guys did that in 4th grade. These individual components, the difficulty level is not high, but you must focus and you must take your time and you must do your best work every step of the way if you plan on having a rock solid superstar answer like your brilliant teacher does right here. Yeah, sparkle star. Secret word, sparkle star. I want to draw with my rainbow pencil a sparkle star on every one of your papers tomorrow, because I want you guys to come into math tomorrow and do an amazing job. Do you see how brightly the star is shining? Because I took my time and I did my best work, and hot dog, I ended up with the correct answer. This star is feeling so happy. I want to put a happy star on all of your papers tomorrow because you are going to be converting your mixed numbers into improper fractions. You are going to remember to add when you're supposed to add, Ollie, and multiply, Claire, when you're supposed to multiply, okay? I don't want any more goofiness tomorrow. Please pay attention to what you're doing. Please know that I know that you know what you're doing. And sparkle star again is the mystery word. And sorry if I was crabby with you guys tomorrow. It's going to be a much better, sorry if I was crabby with you guys today. It's going to be a much better day tomorrow. I think you're great. I'll see you then. Goodbye.